Alright guys, here's a video for 4.1, Simplify Rational Expressions. This is the very first section of Unit 4. So let me go over a few notes that I gave in class yesterday, and this is just the simplified version of everything we talked about yesterday in class. How to simplify a rational expression. What are the steps I need to take to be able to simplify? Well, first, and most importantly, you need to completely factor both the numerator and the denominator. You need to factor it completely. Now, when I say factor, you got to be able to use all the skills that you have of factoring. First thing you do is you look for GCF, and then is it a trinomial? Then you need to figure out how to factor a trinomial. You can use any method you want. You can use the guess and check method. You can use the X factor method, however you feel comfortable. But if you see a trinomial, you need to be able to factor that. And then most of the time, you also see difference of two squares. So that happens a lot. These are the most classical, most common factoring you will see. But you also need to be able to see cube factoring. I forgot to write it here. Cube factoring is another thing you will see very often. So these are all the factoring we've been doing it since Algebra 1 or Math 1 is just factoring of trinomials and difference of squares and now cube factoring. So you need to be able to factor completely. And then, just like fractions, just like if you give me a fraction, I want to reduce the common factors. That's why we have to factor completely so we can see those common factors between the numerator and the denominator. So there's a reason why we're factoring it out completely so we can see what are the common factors. And then you make sure that before you reduce it, actually, there's a step should be right in here. I wrote it as a step 3, but should be right in here. Right before you reduce it, you need to determine the excluded values. We don't want a 0 in the denominator. And then when we have variables in the denominator, we have to determine what values those variables cannot be. So we set the original denominator equal to 0. It can be, obviously, the factored form of the original denominator, but it needs to be before you reduce it. Okay, that's why I try to insert that step right in here. I wrote it in this order because that is how most students see it. They factor it, they reduce it, and then they go back and check for the excluded values. So let's do some examples. Here are your notes. And always refer back to it if you need to. What are the steps that you need to follow? Okay. So let's do one of the examples here. I have a few examples, and then I will do some from your homework. So I have this rational expression. I have this fraction right here. I'm going to do. Let me cover this other example. Let's do example 1 first. Okay. So I have this rational expression. My first step is to factor completely. And then I always look for GCF. Take a look at 4x and -8. They both can be divisible by a 4. So if I factor out the 4, let's divide this term by 4. 4x divided by 4, the result is an x. And -8 divided by 4 is a -2. So there we go. I factored the numerator. Now let's move on to the denominator. I see a trinomial. There is no GCF for this trinomial, so I am going to use I'm just going to go ahead and factor out the two factors. So x squared, I know that x times x will give me my x squared. That's the first term, I take care of it. Now, the factors of -16, that would add to a +6. Immediately, I think of 8 times 2, or 2 times 8. But one of them is going to have to be negative. But when I add them, one of them it's going to have to add up. It has to add up to -6. So I'm going to make a -2 times a +8. If I multiply, I get -16. But if I add, I get -6. So I'm going to put a +8 here and a -2 here. And there we go. I completely factored my denominator. Before I reduce things, I'm going to already decide what values x cannot be here in the denominator. So x cannot be, if x is a 2, I'll have 2 minus 2, which is 0. and that's going to cause problem. So x cannot be a number 2, okay? Because if I put a 2 here, I'll have 2 minus 2 is going to be 0, and 0 times x plus 8, it would cause problem, would have 0 in the denominator. Also, if x is a negative 8, so if x is a negative 8, we'll also get a 0 here, and that's not okay. So we cannot have zeros in the denominator. We're not worried about numerator. We can have 0 in the numerator. What we cannot have is 0 in the denominator, okay? So now that I have my excluded values right here, that is one of the very important answers, check. Now I can come back and reduce common factors. As you can see, x minus 2 and x minus 2 are common factors, and I don't need them. I reduce this fraction. So my answer in the numerator left over is a 4, and on denominator is an x plus an 8. And that is it. A lot of the students think that they can reduce the 4 and the 8, and that is not okay. We have an addition going on. This is a group right here, and they need to stay that way, okay? So my answer is the complete reduced form right here of this original rational expression. This is the reduced form, and this is the values of the denominator the x cannot exist in the denominator, okay? That's how you do it, the 3 steps. All right, let's try one more, and let's move on over here to example 2, all right? Now this is a little bit different. I have a monomial. I don't have an addition or a subtraction going on in here, but here I do have a binomial. So be careful, you have to recognize these terms. All right, so I'm going to rewrite this factors of 18. I see that 2 times 9 is 18, and a y squared, you can write it as y times y. So there we go. I completely broke down, or I factored out. I could write 3 times 3 as well. I could break it down even more, but let's see if it is necessary for me to simplify this even further, to factor out even further. On the denominator, I know that this is divisible by 4, the 4y is divisible by 4, and the 8 is divisible by 4 as well. So I'm going to factor out a 4. So a 4y divided by a 4, it is a y, and a positive 8 divided by a 4 is a positive 2. Okay, and then I don't see anything in common, but I do see that a 4 can be written as a 2 times 2, because I see a 2 in the numerator. So I'm going to rewrite this as 2 times 9 times y, that's my numerator. But I see that I can write a 4 as 2 times 2, that's a 4, and my y plus 2 factor. Okay? So now I can see what are the common factors right here. The 2's are common, and the 2 is not common with anything else. The 9 is not common with anything else down here. This is a group, so I cannot cancel out or reduce with this y. So groups stays together. So pretty much the only thing I can reduce is the 2's. Before I do that, let me decide what values y cannot be. Okay? So let's go back over here to almost to the original. This is the original, this one is second to. They're equivalent. Before I reduce it, if y is a negative 2, I will have a problem in the denominator. So if y is a negative 2, I would have negative 2 plus 2 is 0, and 4 times 0 would be 0. So that is not okay. Y cannot be a negative 2. So now that I determined that, all you have to do is set this equal to 0. Y plus 2 equals 0. Subtract negative 2 to both sides. Y equals negative 2 would give me a 0 on the denominator. Okay? So now I know that y cannot be a negative 2. Now I can go ahead and reduce it. The only common factors here is this 2's. So let me reduce it. And that is my final answer. Now that I'm done reducing, I can go ahead and group them together. This is going to become 9 times y, which is y squared, all over. You can leave it factored out 2 times y plus 2. And that is my reduced rational expression from the original expression. Okay? So make sure you always determine what values y cannot be. As you can see, even here, if you plug in a negative 2, you will have problems, right? So that is how you reduce rational expressions. Notice that in the first example, we had a binomial and a trinomial. Here we had a monomial and a binomial. So you always have to pay attention to these details. So these are my two examples. But now let's go ahead and do some from your homework packet, from the worksheet 4.1. I chose randomly. I just chose letter E first. Okay? So let's focus on letter E. Letter E says I have DB plus DC all over DB. So again, I have a group here. I have a group because I have an addition. I have a group of things here, a binomial, two terms, and I have a monomial here. What do both of these terms have in common? This one have a D, this one has a D. So I can divide both of them by D. So I'm going to factor out a D out, and let's see what we get. If I divide DB by a D, we get a B left. If I divide a positive DC by a D, we get a positive C left. Okay? And then on the denominator is a monomial, is just D times B, and they don't have anything to be factored out. So before I reduce it, I think about what can these letters D and B not be? Okay? So right before I reduce it, D cannot be. If D is a 0 and B is a 2, I would have 0 times 2, which is 0. That's not okay. So D cannot be 0. How about if B is 0? That also causes me problems. So B cannot be 0. Okay? So you always pause right before you reduce and determine the values that the variables cannot be. And then I go ahead back to it and I go and reduce it. So multiplying by D here and multiplying by D on the denominator, it's not needed, so we reduce it. I don't need to multiply by D and then divide by D. So our final answer simplifies to B plus C all over B. Now again, the common mistakes that students make is they think that they can simplify this B with this B. This is a group. You cannot reduce that. And let me explain why you cannot do that. If B was a 2 and C was a 3, plus a 3, divided by, let's pretend B is a 2. There we go. So if B is a 2, you would have 2 plus 3 divided by 2, which is 5 over 2. But if you reduce these B's, you would have the answer to just be a 3, and that is not true. So do not reduce when you have a grouping, okay? So this is just a little side note, why I cannot just reduce it and say that the answer is a 3, because it's not. You have a group of values being added together and then divided. So do not reduce it, okay? All right, so that was from your homework. Now let's do this other letter from your homework. So this is letter K. Before I even factor things out, I try to recognize what kind of factoring I'm going to do here. When I look at this, I see that is a difference because of subtraction, of two squared values, of two squared numbers. So I have a difference of squares. So I'm good at that, so let's factor that out. We know the difference of squares is the first term, a times a, it gives us a squared, and also whatever the square root of 49 is, which is 7. So I'm going to have a negative 7 and a positive 7. Okay, multiplying those gives you negative 49, and a times a gives you a squared. So that is a difference of two squares. And then in the denominator, I have a 7 plus an a. Remember, we have addition or subtraction. We have a group. Okay, this is a group of things that cannot be separated. All right, before I reduce it, I decide what a cannot be. If you set this little binomial, 7 plus a equal to 0, you will see that if you subtract 7 to both sides, a equals negative 7. So a being negative 7 will give me a 0 in the denominator. So that a cannot be a negative 7. Okay? A cannot be a negative 7. Now that I'm done deciding that, I can come back and reduce common factors. A plus 7 is the same as 7 plus a. So I know that these are the same terms, they're just written in different order. So I'm going to go ahead and reduce these common terms. And the final answer is our numerator of a minus 7. It is a group. You can put them as a group, or you can put them just a minus 7. And that is our final answer. Okay? All right, let's do one more. And I chose letter C. Let's do letter C, and then we'll go back to letter O. All right, let's take a look at it on letter C. I have a really big monomial. There's no addition and subtraction. It's just a bunch of multiplication here. 30 times a to the 5th times b cubed times c to the 4th. And in the denominator, I also have a monomial. Okay, it's a big long monomial, so we have to be careful. If you want to see a 30 as a factor, try to think of the numbers that multiply that gives you 30. I see 5 times 6, and if we need to factor a little bit more, we can, but let's start with that. A to the 5th is a times 8, 5 times, but I'm not going to write that. I'm just going to do a to the 5th times b cubed times c to the 4th. Okay? 24 is 4 times 6, right? 4 times 6 is 24. So I try to look for hints on the numerator of what could I do with the denominator. And then I have a squared, b cubed on the bottom, and a c to the 9th. There is a rule of exponents that says if you have x to the a all over x to the b, they are the same number, the same base, but different exponents. You can subtract. It becomes x to the a minus b. This is a rule of exponent that we can subtract the exponents. And I'm going to apply that rule of exponent right here. Right before I do the reduction, I'm going to decide what these letters cannot be. A cannot be 0, because if a is 0, everything here is going to multiply times the 0. B cannot be 0, and C cannot be 0. None of them can be 0, because then we're going to have 24 times 0 times everything here is going to be a problem. Okay? All right. So now that I determined that this cannot be zeros, I'm going to go ahead and reduce all the common factors. The 6 are common, so we're going to reduce it. I'm going to use this rule of exponent right here that says I can subtract the denominator exponent from the numerator. So 5 minus a 2, so this 2 from here, and 5 minus a 2 is going to become a 3. And 3 minus 3 here is going to become a 0. And 4, I have a 4 on the top, and I can subtract from here, and we end up with a 5, c to the 5, to the 5th power. So I reduce all of these. We end up with 5 over a cubed, the b's reduced, and the c to the 4th, I subtracted from the 9th here, and I end up with 5. So in the numerator, all I have is 5a cubed. In the denominator, we have a 4. The 6 reduced. The a squared, I subtracted the 2 from the 5 here. The 3 from the 3 up here. And that was 9. 9 was bigger on the denominator. So I subtracted the 4 from the 9, and we got a c to the 5th. Okay? So that is my final answer. Final expression reduced is 5a cubed and 4c to the 5th. And a and b and c cannot be zeros. And I'm done. Okay? So practice this rule of exponent here, where you subtract the smaller exponent from the bigger, and the resulting, the leftover has to be where it is. Notice that we subtracted 4 from 9, I left 5 on the bottom, because the 9, there was more left over on the bottom here. Okay? All right, so let's go ahead and move on to the last one, which is letter O. So letter O says, I have an a minus a 4. I have this long polynomial here with 4 terms. Whenever we have 4 terms, we group them 2 by 2s. You can do that. Some students prefer to combine like terms because they see negative 8a minus 3a, they can be combined and turned into a trinomial. There's 2 ways of doing this, and you can choose which way you want to do it. I'm going to go ahead and approach it in this way. Okay? So let's go ahead and leave the numerator alone. A minus a 4, because it's a group, there's really nothing I can do, is already simplified. 2a squared minus 8a, they're both divisible by 2 and by an a, so I'm going to factor out a 2a as my GCF. 2a squared divided by 2a is just an a. Negative 8a divided by 2a, that would just be negative 4. That's nice because it looks like something in the numerator, so it looks good. So let's continue. If I divide a negative 3a by a negative 3, that looks good. And also by the 12 is also divided by a negative 3. So let's factor out a negative 3 and see what happens. Negative 3a divided by a negative 3 is an a. And the positive 12 divided by a negative 3 is a negative 4, which it looks really nice. As you can see, I factored this completely from here. And there's one more step. We'll leave the numerator alone. There's nothing to do to the numerator. But see that these two terms right here, these two factors, and the last two factors, we can factor out the a minus a 4 from both of them, okay? If I divide these two terms by a minus 4, we get 2a left over. If I divide these two values over here, these two factors by a minus 4, we get a negative 3 left over. There we go. So it's completely factored. What was the original rational expression? I completely factored out. They are equivalent, but I am almost about to reduce it. I have to decide the values that a cannot be. How do I do that? I don't have to guess it. I set each of the factors equal to 0. So if I set a minus 4 equal to 0, you add 4 to both sides, a equals 4 it's going to cause us a problem. So a cannot be a 4. If I set 2a minus 3 equal to 0, and I solve for a, I'm going to add a 3, so I would have 2a equals 3, and then divided by 2, we would have a equals 3 halves. So a cannot be a 3 half, so we write that down right here. A cannot be these two values. If a is any of these two values, it's going to cause us to get a 0 in the denominator. Now that I decided that, I can go ahead and reduce it. If I reduce a minus 4 and a minus 4, we end up with a 1 in the denominator. And then we end up with 2a minus 3 in the denominator. So our final answer is 1 over 2a minus 3. You can put your grouping in there, parentheses, to keep them together. And here's our final answer. Okay? So as you can see, we are using skills from before of factoring, deciding the denominator, the excluded values from the denominator, and then finish reducing common factors. All right? So we're using previous knowledge of factoring and then reducing. And that should be enough help for you to practice this concept a little bit more. So good luck, and come and ask me for help if you need any.